Hello everyone, my name is Nick, and today we are going to be going over the remove people function in the final project called elevators, and this function exists in floor.cpp. Okay, let's go ahead and we'll get started with the RME. So if we scroll down, we see down here we have the function remove people. If you look at the modifies clause, it's going to modify the people array, which is a private member of the floor class, which contain a bunch of people on that floor. And then it's also going to change num people, which represents the number of people stored inside of that array. Okay, we'll look at the effects clause. It says removes objects from people, so from the people array, at indices specified in indices to remove, another array, which is an input to the function. Okay, and then it says the size of indices to remove is given by num people to remove. So basically, we call this function, we're going to pass in an array which will contain the indices where we want to remove people inside of the people array. And it will also contain num people to remove, which, just as the name might suggest, contain the number of people that we want to remove or the number of indices inside of indices to remove. Okay, let's go ahead and we'll get started with reading the description. It says, in order to preserve the integrity of the people array, when we remove people from the array, which happens 2 times, number 1, either after they're picked up, so the elevator goes to a floor, we grab some people, they're no longer on that floor, we want to remove them. So that's the first case. Or the second case is after they explode, right? If they've been waiting for too long, their anger reaches max anger level, they explode, they no longer are part of the game, we want to remove them from the floor as well. Okay, those are the 2 places. So in those 2 cases, we need to ensure that the rest of the people, right, the people in the people array, remain in contiguous slots in the people array. What that means is we don't want there to be gaps, right? So if I remove someone from the middle and another person from the middle as well, we don't want there to be gaps in the end. We want to shift everybody down, all right? So this function is responsible for removing the people specified in indices to remove, updating num people, as I mentioned before, as well as making sure that the rest of the person objects in the array remain in the first num people slots in the array. So what that means is if we had 7 people to begin with, they'll exist in indices 0 through 6, making 7. And then if we end up, after we call this function, with just 4 people, we want them to be in the first 4 slots of that array in indices 0 through 3. Okay, remember, if you remove people, up and down requests on the floor may change. Make sure to account for this in your code. So let's think about why this might be, right? If we're on a floor and there are a bunch of people and only one of them has an up request, if that person gets removed, so they get onto the elevator or they explode, there are no longer going to be any up requests on that floor. They're only going to be down requests. And there's a very simple way that we can reflect this in our code. It's just going to be a function call of reset requests. Basically what it does is it just updates, has up request or has down request. So we can call that function inside of this function. Okay, let's go ahead and we'll take a look at this example. So we see on the very first line here, we have a picture with 7 people contained in indices 0 through 6, right? 7, 8, and 9 are the remaining 3 slots. We don't care what's in there because num people right now is 7. So we only care about the first 7 slots of this array, not the last 3. Okay, so we call remove people. The first argument is the array called indices to remove, which contains the indices inside of people that we want to remove. In this case, it's 0, 2, and 5. So we look at 0, the blue person will get removed. At 2, the yellow person will get removed. And at 5, the purple person will get removed. And that number is reflected with 3. There are 3 people inside of that array, and we remove those 3 people. In the end, we see that we now have 4 people. 7 minus 3 makes 4. And they're in the first 4 slots, 0, 1, 2, and 3. And then they're all right next to each other, right? And they're in their original order. So we didn't have this this green cross in front of this orange lightning bolt. We see that it goes lightning bolt, green cross, black star, and then red bubble, right? Always in the same order as the one that we started in. Okay, so what we're going to do now is I'm going to hop down to the iPad and we're going to walk through how this function would work step by step. Okay, one quick thing that I forgot to mention in the previous part is that for the array called indices to remove, those numbers can be in any order. So in the example that we gave on the project spec, 0 to 5, if that were 520 or 205 or 502 or any other permutation, it should accomplish the same thing. It doesn't matter which order we pass the indices in, we just want to remove those people. Okay, so for simplicity's sake, I changed the pictures into letters A through G to represent the 7 people. And then I put question marks in indices 7, 8, and 9, which represent the stuff that we don't really care about, right? We only care about the first 7 people. Okay, so we make a function call, right, to remove people. The first thing that gets passed in is going to be the array. I'm going to make it so it's not in the same order as the specs. So we will say 205, right? It should accomplish the same thing. And then that is 3 people. Okay, so let's go ahead and we'll get started. The first order of business is it might be a good idea to sort this array called indices to remove, right? Because we need to make sure that we remove all those people, and having it in a sorted order is just going to make our lives a bit easier.
Hi, everyone. Now we're looking at the floor.cpp file and working on strategies for remove people. And we're going to start now with sorting the indices to remove parameter. So here are the 4 steps we're going to use to sort our indices to remove. Step number 1, we want to start from the top, pound include algorithm. So start right under pound include floor. This step is exactly what it looks like. That's going to give us access to a sort function we'll use to sort the array. So step 2, make a copy of the array since the parameter is const. Remove people has 2 parameters. One array of integers declared as const. This will not allow us to be able to sort the parameter directly or to modify it in any way. And the other variable, the other parameter is num people to remove. So for step 2, we're going to start by making a copy of the parameter indices to remove. So for step 2, we're going to need to make a copy of the parameter indices to remove. We want to sort indices to remove from least to greatest. However, the parameter is declared as const, and this will not allow us to modify any of the contents of the variable indices to remove. So we're going to need to start by making a copy. I'm going to name my array targets to remove and declared it the same size, max people per floor, as the parameter, and initialized all of the values to 0. Now that we have our array that we're going to eventually sort, let's copy all of the elements from indices to remove. Note, we're only going to be removing num people to remove, so we can have the stop condition of our loop be num people to remove instead of max people per floor. Now we've copied all of the values that we're going to need from indices to remove to targets to remove, and we can move on to step 3. sorting our targets to remove. To sort our targets to remove, we're going to use the sort function, part of the algorithm library that we included at the top of the file. This function takes two arguments, the very first element to sort and the very last element to sort. So the first element to sort is defined by our array name targets to remove. Targets to remove represents the entire array, but it is also the location of the first element of the array. For the location of the last element that we want to sort, we're going to use numppeople to remove, but the end element is the start plus the number of elements added. So we're going to have our targets to remove plus numppeople to remove for our last element that we want to sort. And indeed, this will sort all the values in targets remove from the smallest value to the greatest value. Now on to step 4. For the remainder of this approach recorded in the video, we're going to use targets to remove instead of indices to remove. So because the parameter was declared as const, we are not able to modify it. So we needed to make a copy, copy all the values from indices to remove to our copy, sort the copy, and now for the rest of our strategy, we'll use our copy targets to remove everywhere you would have used indices to remove.
And now we have it in the order 0 to 5. And numppeople is still equal to 3. Okay, so step 1, sort indices to remove. Okay, now that we have that sorted, we can go ahead and get started with removing people. And there are going to be two approaches, right? We know that no matter what, we are going to have to go through indices to remove one by one, and we're going to have to remove the people that we see there. So in this case, we could either work our way from left to right. So approach 1 is left to right. We can say first remove the person at index 0, then remove the person at index 2, then remove the person at index 5. Or approach 2 would be working our way from right to left. We say remove the person at index 5, and then remove the person at index 2, and then remove the person at index 0. This should both accomplish the same. These should both accomplish the same thing, but one of them might be a bit easier than the other, and we'll see why in a second. Okay, so let's start with the left to right approach within indices to remove. So we'll say step 2, remove people. And again, we'll go over the first approach going from left to right, and then we'll go over the second one. So this is going to be approach 1. Left to right inside of indices to remove. Okay, so how are we going to do this? We're going to need some sort of loop, right, to go through all of the indices and indices to remove, and we know the size of that array, so that should indicate to you which type of loop we're going to need. Okay, so we'll start with person 0, right? I'm going to go ahead and copy this down here, so we know where we're working. Duplicate it and move it down. And then again, I'll redraw the indices to remove. Right here, it's 0 to 5. Now, on the first pass of this function, what we're going to do is start with person at 0. So we're going to get rid of 0, so A, and everybody else is going to shift down to the left by 1 spot. So B moves to spot 0 from index 1, C moves to index 1 from index 2, and so on. Okay, that was the last person, right? So now what it looks like is we remove the person at index 0. So we start with B, and then we get C, D, E, F, and G. Okay, so now instead of having 7 people inside of this array, we have 6 people, right? We know we have to update num people. So we say num people, right? We're going to subtract 1. It's going to give us, instead of 7, we have 6. Okay, so that was the first pass. Now what we're going to do is we are going to go and we're going to get rid of the next person. So this goes over to 2 in the next pass. So we're going to remove the person at index 2. Okay, let's go ahead and see what happens, right? So the person at index 2 in this case is going to be the letter D. But that's a problem. Why is that a problem? Let's go ahead and we'll take a look. So index 2 in the original contained C, but since we shifted everybody down by 1 spot, C is no longer at index 2. C is at index 1, right? This is the problem I was alluding to with approach 1. It's that after we shift everybody down to the left, their index has decreased also by 1. So we're going to need to take that into account. So one easy way to do that is we're going to go through indices to remove, and we'll just subtract 1 from each, right? And that should take into account for us this shift. So instead of 0 to 5, we now have -1, 1, 4. Do we care about this -1 here? No, we don't care about that because we already took care of it when it was 0. And right now we are working on the next one, which is going to be the person at index 1, right? So it's not going to be D, it's going to be C right here. Okay, so we'll go ahead and we'll remove the person at index 1, put an X, and everybody to the right of that person is going to get shifted down 1 spot. So D moves to the left, E moves to the left, and so on. Oh, that was the last person. Okay, so we'll go ahead and we will update our picture to reflect this change. Okay, so we have B first, C was removed, D gets shifted down 1 spot, so D, and so on, E, F, G. Okay, right, we've removed 1 person, so we have to make sure that we update num people. So num people -1, instead of 6, we start with 7, became 6, became 5. All right, amazing. And again, we don't care about everything else in there. All we care about are the num people that we have. Okay, so now this is going to be the last pass, right? We've taken care of the first 2. Now it's going to be the last one. So -1, 1, 4. Oh, but we have to remember, right? Everybody shifted down. So their original index now is going to be 1 less. So let's go ahead and we'll fix that. So from before we had -1, 1, 4. Now we have -2, 0, 3. And again, we don't care about this -2 because we've already taken care of it. We don't care about this 0 because we've already taken care of it. The next one that we care about is going to be at index 3, right? Let's just double check to make sure that's correct. Originally, we had it at 5. 5 contained F. Now, if we check index 3, oh, perfect. Index 3 now contains F. So we know that we're on the right track. All right, we go ahead, we remove that person, and everybody to the right of them is going to shift down 1 spot. In this case, we only had one person. Okay, so let's go ahead and update the picture. So now, we are going to say our picture looks like this. B, D, E, and then G was shifted from index 4 over to index 3. So G is here. And again, we don't care about everything else because right now, num people is only 4. So there could be anything inside of there. We don't care. We only care about the first 4. So again, num people minus 1 equals 4. Okay, so if you look back at the original picture in the spec, we see that we have duplicated the output of this function, right? We have duplicated what happens. So we only have 4 people, B, D, E, and G. We have removed the people at indices 0, 2, and 5. So that was going to be, if we take a look up here, at 0, we had A, at 2, we had C, at 5, we had F. We look down here for those things. Do we see A? Nope. Do we see C? Nope, I don't see it. Do we see F? No, I don't see it. And then the original order would be B, D, E, G. Perfect. B, D, E, and G. Okay, so that was approach 1. Oh, one more thing that we have to do, right? If we removed somebody and they were the only person with an up or a down request, we need to make sure that we call the function update or it's not update priorities, my apologies. Let me double check the name of this function. Let's see. Reset requests, my apologies. I was thinking of a different project. So we're gonna call the function reset request. And that's going to take care of everything for us, updating the up request and down request for every single person inside of there. Okay, so that is approach 1. And again, I'm just going to touch back on the limitation of this. It's a little bit weird because after we shift people down, their index also shifts down by 1 spot. This is the downside to using approach 1. It's totally a valid way to do it, but some people might prefer to use approach 2. Instead of going left to right inside of indices to remove, we're instead going to go right to left. So let's take a look at approach 2. Right to left inside of indices to remove. So again, we'll start with the original picture this time. E, F, and G. And again, there are only 7 people here. We don't care about what is in here. So we have those 7 people. We make a call again to the function removePeople. I will just go ahead and copy and paste like a lazy person. Just like this. Duplicate, move it down here. Okay, so removePeople in approach 2 is called with 205. Again, 205 could be in any order. We don't really care, right? Because in the end, it's going to accomplish the same thing. But instead of what we did with approach 1, we're using approach 2, where we're working our way right to left inside of indices to remove. So let's take a look. We are going to start right here with 5, and we'll remove them first. So we see the person at index 5. Oh, I'm sorry, we forgot to sort this, right? Okay, let's sort it first. 0, 2, 5, right? So step 1 was sort. Okay, 0, 2, 5. Okay, now we can start with step 2, which is remove. And we're working our way right to left, like we said before. So the first index is going to be at index 5. So I will go ahead and we will say, all right, the person at index 5 has to go. That's F. Everything to the right is going to shift down. So G gets shifted down from index 6 to index 5. and we'll update our picture to reflect that. So A didn't move, B didn't move, C didn't move, D didn't move, E didn't move, F was removed, and we moved G down one spot. So G goes into spot 5. Okay, amazing. We have to make sure that we update num_people. So num_people -1. And that will give us 7 becomes 6, right? And then we'll just copy down the indices one more time to see what we have. We had 0, 2, and 5. Amazing. Okay, now we're going to do the next pass, right? We started with 5. Now we're going to do 2. 5 from before, 2 now. So the next target is going to be the person at index 2, which is C. If we look back up in the original, right, the person at index 2 was C. Since we're working away from right to left, the things to the left of wherever we started on the right, those didn't move, right? The only things that moved, the only people that moved were the things to the right? So from 5, indices 6 through 10, if they exist, all get shifted down. But to the left, all those things are still in their original place because we didn't touch them, right? And that's the benefit to, excuse me, that's the benefit to approach 2. We don't have to worry about adjusting the indices. Okay, let's see here. So we're going to get rid of the person at index 2. Everybody is going to get shifted down. Okay, so we have, let's see, right there. We'll use the other color. Okay, so everybody to the right gets shifted down. D goes to spot 2, E goes to spot 3, G goes to spot 4. Okay, we'll copy that over. A, another color issue, my apologies. We say A stays where it was, B stays where it was, and then all 3 of these people get shifted down. So D moves to spot 2, E moves to spot 3, and then G moves to spot 4. We do not care about what is left over here. Right, we're going to update num_people, right, because somebody was removed. Equals 5, right? And then we still have the original array of the indices that we want to remove, which was 0, 2, and 5. Okay, that was pass 2. Now this is the last pass, right? We've taken care of the person at 5. We've taken care of the person at 2. So now we take care, moving our way right to left. The last one is the person at index 0. So A has to go, right? We're going to cross A out, and we're going to move everybody else down by 1 spot to the left. All right, that was everybody. So we'll go ahead and we'll update our picture. Okay, back to blue. And now we see that person A is gone, and all these people get shifted down. So B goes to 0, D goes to 1, E goes to 2, and then G goes to 4. Okay, we've worked our way from right to left, and we've successfully removed every single person. Let's just double check to make sure we didn't make any mistakes. So we go back to the original. We see we had A through G in spots 0 through 6. We wanted to remove the person at index 2. So we want this guy to be gone here. I'll do a different color. We want this person to be gone here. We want index 0 to be gone. So we want this person to be gone. And we also want the person at index 5 to be gone. So we want F to be gone, right? Let's check to see if we see A, C, and F in our last thing. I don't see A, I don't see C, and I don't see F. Okay, so we know we removed all the people. Next thing we have to check for is to make sure that we preserved the original ordering, right? So B, D, E, and G should be what we see in that order. Perfect. B, D, E, and G. Amazing. And then I won't forget, like I did last time, if we remove somebody and they were the only person with up request or down request, we know that the status of up request or has down request has changed on that floor. We just make a simple function call. I won't mess up the name this time. It was called reset requests. So we're just going to call it reset requests. And that should take care of resetting has up request or has down request. Okay, everybody, I hope you were able to find this, this project video useful. Again, you're going to have to decide if you want to use approach 1 or approach 2. Both of them will accomplish the same thing as long as you execute them correctly. It just depends which one makes more sense to you, right? Yes, okay. So happy coding, good luck on the final project, and I will see you guys in office hours. Thank you.